to this point in this course, we've been dealing with angles as measured in degrees. And a lot of applications are going to have degrees as the preferred method of measuring an angle. But there are some applications where we actually want to use a different kind of measurement. And you might think at first that this radian, which is this other form of measurement, might seem a little complicated, but it actually makes a lot of things simpler. So what is a radian? Well, first we're going to have to define this as being the measure of the angle that has a particular set of properties. So the first thing is that we're talking about an angle that has a vertex at the center of a circle. Then, if we were to look at the angle and the arc that it intercepts, so you can see here we have this angle in the center of the circle, and I'm talking about this blue arc, the arc that is intercepted by that angle. If we were to mark off exactly 1 radius worth of distance around that circle, so we take that straight radius and we curve it around the circle, that's going to equal the 1 radian. So let's go through that one more time after we write this down. So we are talking specifically here about the angle that is formed that intercepts the arc that has a length of 1 radius. If we were together and face to face, what I would have you guys do is I would give you a circle and I'd have the center marked, and you would take a piece of string and stretch that string from the center of the circle to the edge of the circle. So you have a radius there in your string. Now, I want you to imagine taking that string, that's the length of the radius, and then wrapping it around the outside of the circle. Where that radius starts and stops on the circle is measuring off exactly 1 radian. And so we start here at the bottom, we wrap our string around the circle, and we stop there. That angle is going to be what 1 radian is. So it's kind of a strange relationship here, but it's actually interesting to think that we're measuring an angle based on its ability to capture a radius. So 1 radian is equal to 1 radius around the circle. If you're in a bigger circle, you have a bigger radius, which would mean that that radian would be longer, but it's still going to be the same angle. You still have that same ratio. So let's put this into a perspective where you'll actually see why radians are quite useful and an actually more appropriate way to measure angles around a circle. So think about the distance around a circle. That's the circumference. So we talked about that earlier in this course, and we remember that the circumference is 2 times pi times r. So if we were to go around this circle with that radius length, and if we were together, I would have you do this as well. You would wrap that radius around once, and then again, and then again, and then again. If you're looking at this formula for c equals 2 pi r, you should see where we would need to go around the circle 2 pi times. Now, that's going to be impossible to measure, but it would take 6 and about 1/4 for you to go around that circle using that string that's the length of the radius. If we could measure precisely enough, it would be exactly 2 pi. But 2 pi is about 6.28, and that's about how many times that you would go around the circle with this piece of string. So we see this relationship between the circumference and this radian or radius. It takes 2 pi radians to go around the circle. But we also know that around the circle is 360 degrees. And you probably have just accepted that it's 360 degrees and never once thought about, why are there 360 degrees in a circle? There's actually a whole lot of reason why that was the number chosen, and if you're curious, you can find that on Google. But for right now, I want us to recognize that 360 degrees forms that circle, and it takes 2 pi radians to form a circle. So if we set those equal to each other, 2 pi equals 360 degrees. Those are both measuring going around the circle. Well, let's divide both sides by 2. And that's where we see that pi radians is equal to 180 degrees. That's something that you need to remember, or at least have written down somewhere. Now, if we are trying to solve or trying to go between radians and degrees, we are going to need these little formulas. 1 degree is going to be equal to pi over 180 radians. 1 radian is going to be equal to 180 degrees over pi. So how do we actually use that? Well, here we have 180 degrees, and honestly, we could just say that it's equal to pi radians because that's a definition. But how would we do the math to show that? Well, you would take this 180 degrees, and we see that 1 degree equals pi over 180 radians. So 180 degrees equals, 180 degrees times pi over 180, and that 180 and that 180 cancel, and you're left with just pi as being your number of radians. So let's do another one of these. We have 240 degrees, and since 1 degree is equal to pi over 180, then we're going to multiply this by pi over 180. I like to leave my answers in terms of pi. So here I would not include pi in my calculator calculation. I would just take 240, divide by 180, and I get a decimal, but I can turn that into a fraction. That is equal to 4/3 pi. Now, you could have left it 1.33 pi, and honestly, in applications, it probably would have been helpful to have an approximation 4.19, and all of these are in radians. Now, how do we go from a radian to degrees? Well, we use the other formula where we know that each radian is worth 180 degrees over pi. So if we start with 1.6 radians and we multiply by 180 divided by pi, and here I just go ahead and type in the pi as well. So I do 1.6 times 180 divided by pi, and we get that this is approximately 91.7 degrees. And then 0.5 radians, we do the same thing. Each radian we need to multiply by 180 divided by pi. And so when you take 0.5 and multiply by 180 and divide by 3.14, you get that this is equal to 28.7 degrees. 2 ways to describe the same angle. You can describe an angle in degrees, you can describe an angle in radians.